and welcome to another episode of The Focal Thought. My guest today is Keanen Rodrigues. How are you, Keanen?
Doing well. How are you?
Good, good, thanks. Thanks for coming on the show today. So, Keanen, you are a field service engineer and an aerospace engineering graduate. So I'm excited to speak with you today on the topic of aerospace. It's something, when I was a kid, I used to dream about being a chemical engineer because my uncle was a chemical engineer. And then, kids being kids, the following year, that changed to aerospace because I might have seen a cartoon somewhere. So I wanted to ask you, aerospace, first off, primarily deals with everything that is atmosphere and then above air, right? So outer space. So technically, when you're hitting orbit, right? So anything to do with the term aerospace, whether it's the commercial aspect, industrial, the engineering aspect, everything is from that suborbital point onwards, correct?
I would say that's right. Um, Generally, anything above ground, uh, including above the sea, would fall into the aerospace category and extending into outer space.
Into outer space. And outer space is not really, I mean, that far, right? I think they say it's about maybe 9,500 kilometers, above us. And essentially that's, if you're driving at
It's an hour's
120,
trip. Yeah.
that's a 50-minute trip, right, in the car. So it's really not that far for us. And we tend to think it's much further than, we anticipate.
Well, I think that has to do with us having a lack of a point of reference up there. You can't really look at the sun, and even then, it's kind of surrounded by a vast emptiness. So Uh, it might look a lot further than it is. And then again, these things like other planets or the sun, which is a star, those things are pretty far as opposed to outer space itself, which is just at the uh, outer limits of our atmosphere.
Got it. Yeah, that makes sense. So, I mean, if we're on land, if there's a landmark building in the city we live in, we can sort of gauge our distance, to that building. But like you're saying, if you're looking up, it's really very hard to, have a point of reference because even if you look at the moon, there's different phases of the moon and, the distance between the moon and the earth, all of that changes. So that's a good point that you make. How did you get into the subject of aerospace? Was it something when you were young you were influenced by, like myself, maybe, a cartoon or a movie, or how did that come about?
Yes, very much so, actually. It all started when I think I was watching this show called Meet the Robinsons. It was a movie, and it was, long story short, about time travel, and they had gone into the future at one point in this film, and I saw flying cars or planes, I guess. And although I think more people might have gravitated towards the time travel aspect of the movie, I it got me thinking that it probably couldn't be that hard if we had planes to make kind of cars that could fly. And then I got to thinking about things that I considered more fun at the time, and I settled on trying to create a hoverboard. So that was
Nice.
kind of my inspiration.
And were you
Um,
successful? Did you end up creating one?
so by the time I'd started my first year in university, there was a military project that had succeeded in developing you might have seen this, it's a water powered propulsion device, almost like a jetpack. And the military, I think, somewhere in Europe was able to use that to take a 30-minute trip across a body of water. Uh, that inspired a bunch of development into that sector utilizing, I guess, alternate propellants. And that led to people in California developing the magnetic hoverboard. So that kind of put a pin in my work because I saw myself as trying to be the first one to do something. And so I pivoted at that point towards trying to figure out how to, instead of make a hoverboard, create shoes that would function similarly.
Okay, so the shoes have the technology built in.
That was the goal. It is currently um, not practical because to obtain the power necessary, there's actually a lot of limitations to it that I discovered as I kept trying to make that work. And maybe I could get into those right now.
Sure.
So one would be the power aspect. One example I'll use is that water propelled jetpack that the military used. That was extremely power heavy, and it's one of the reasons that actual jetpacks aren't feasible. Uh, to contain so much power to spin a turbine at high enough speeds to say lift an average weight person off the ground consistently uh, would not be possible at this moment with the battery technology that we have.
Yeah.
It is promising that we're heading into the electric vehicle movement now, and there is development on that side of things, which could pave the way to having this no longer be an issue. But then you get into the other issues such as stability and control. And so having a separated having two separated propulsion systems on either leg um, is a very unsafe thing. You we as humans have joints in our knees, and they wouldn't do too well considering you might slip or you might not be able to balance the force well enough when you're just starting out with say getting used to this technology in a test, and it would have very disastrous possible consequences. So for the time being, it seems that I've had to put this project on hold as I further my career.
Got it. And you never know. I mean, with the advent of new technology coming out and, the work that they're doing with quantum computing, because, I guess we watch these movies and, in my own life, I look at Back to the Future where they had the hoverboard, right? The skateboard.
Right.
That was a hoverboard. And then if we look at Star Wars, that's the practical version of the jetpack, right?
Right.
And we look at it and we take it for granted that, okay, in our imagination, this is easy to create. But then when we actually get down to the engineering of it, then we get into the limitations, right? I mean, we see that with Elon Musk right now, where he's trying to, launch the spaceship Starship. And I think today was supposed to be one of the launches, but then they canceled because they found a frozen valve or something like that.
Okay.
Uh, so again, he's got it in his mind. He's already created it, but then when you actually get down to the engineering side of it, then you realize what limitations you're dealing with. And it would seem that something like a jetpack might be easy enough to do. I mean, compared to, Elon's Starship being reusable. But like you're saying, the technology is maybe not just there yet, right? To make it compact and practical enough to have it as, easy to use as our smartphones.
Right. That's pretty accurate. Elon Musk has an abundance of funding, and that is something that's necessary, I believe, for engineering development,
Yeah.
because you do need to fail to succeed sometimes. And as you push the boundaries of what is possible, that ratio of failure to success seems to tip towards failure. And so developing things is generally the most expensive part of production,
The research and development.
research and development.
Yeah, no, that's very true. I mean, we look at a lot of the great inventions that have come out, through the military, right? Like the microwave, the internet, things like that. And, that is with a lot of, funding behind them. And even Amazon, like with Jeff Bezos, he's always been an advocate of setting money aside into research and development. And, that's how they're able to fine tune the business and make it even better because, yeah, like you're saying, a lot of money has to go into developing. And sourcing that money, that becomes a business in itself, right? Because again, the technology is not there yet, right? And it takes a lot of, like you're saying, trial and error to get there, a lot of burning money, right?
Right.
And sort of resources to achieve that result.
Right. And so, what I've personally experienced in my career was first initially during my cooperative internship during university, I joined a team that was responsible for engineering improvements on existing technology. And so, what we would do is we would have clients come to us with their current designs, and they would either want it to be cheaper, want it to perform better, or both. And given that some of these things may have come around the early 2000s or late 90s, um, technology had advanced far enough where we could change, say, like a capacitor on a circuit board that they had somewhere and either marginally improve the cost but drive up performance or vice versa because technology had just progressed so much so that these small parts now are just so much better than they used to be. And so it's kind of like an ongoing process, and research and development doesn't necessarily stop as we seem to be moving forward in technology.
Correct. And we do need it to move forward. And the rate that we are thinking and progressing right now as a collective, that is moving much faster than the technology is there to support us. And we can see with human genome sequencing, if it wasn't for maybe AI and quantum computing, we might not be as ahead today as we could have been. Or rather, as ahead today without the use of that technology. And even if you look way back, when early, you know, astronomers were looking into the moon, it took literally centuries before someone actually was able to get to the moon, right? So even in their mind, they had already landed on the moon, but physically being able to go there, that's a very different thing. And you do need the technology to meet you at the space of acceleration. And you're right, it requires massive amount of funding because there's a lot of trial and error involved. And in order to get that funding, you need to have people agree, with your goals and objectives so that everyone's on board and, supports the campaign.
Right.
With these different sort of propellants, like, with the jetpack, say, we're looking at a water-based, propellant. And then there's different technologies as well, right? With the jetpack, like air-based. And is
Yep.
there one
We
that you think might come out the winner in terms of, getting to that practical application? Is it water or air or some other sort of source fuel?
Well, in recent news, if you look at one of Porsche's new announcements, they have announced that they're developing I think it was either hydrogen powered or water powered engine that utilizes hydrogen. And that would contribute in multiple ways to a possible um, alternative source of fueling.
Yep.
However, I do believe that although there's a lot of benefits to that fuel, in which such as reduction of emissions, increased efficiency as compared to petroleum, uh, I think we could probably find even more either environmentally friendly or fuel efficient um, or propulsion efficient fuel sources, such as, um, say, magnetism. Like if you look at the maglev trains in Japan, uh, they had to build the infrastructure around it.
Yeah.
However, those things operate on no resistance at the lack of wheels there at the bottom of the train, the base. And so all of the braking or acceleration there is due to magnetism, and
Yeah.
it does take some electricity to power that. But if we were able to, say, utilize that in a better way, uh, I think it's possible that that could be uh, a very beneficial fuel source or propellant.
What are your thoughts on nuclear energy as a fuel source? I mean, no one wants to have a jetpack that's maybe, nuclear power contained, but it might, be the most efficient maybe for harnessing that volume of power you speak of.
Right. I think if we are able to better contain the radiation that comes with that power, um, it could definitely be, honestly, I think it is the most efficient or most dense fuel, I think would be a better way to word it, that we have access to at the moment. And the problem is that we, our planet and the things on it can't really handle that radiation all too well.
Yeah.
And I think every fuel has its pros and cons. And if we pick a battle or pick a couple of battles and push them as far as we can go in that R&D aspect of things, we
Yeah.
could we could get somewhere. But I think we are possibly as a race struggling to figure out the best course of action and plot that forward, given the rapid rate of like climate change and the pressing nature of the environment and its
Yep.
collapse.
And right now with auto vehicles, there's a mandate put out that in 2035, the sale of gasoline cars will, no longer be regulated, right? So they're canceling that component, and everyone's betting on the EV component that the cars will succeed with electric fuel. Do you see that happening? Within that's pretty much the next 10 years or so.
Yeah, just about. I I've looked into that, and as part of my studies in aerospace engineering, we studied engine design, and I worked in a student group where we powered a rocket through a liquid propellant, so basically a gasoline or an alternative. Um, I don't personally think that the electric vehicle direction is the right one. I think that in maybe 20 years' time, when these lithium batteries inside of those cars start going out, and these batteries are currently like 15 to $25,000 anywhere in between to get replaced. That's a financial limitation because without the battery you won't be able to start the car. But there's also the environmental impact that goes into mining that lithium. And while we can get a positive net trade-off in emissions at the end of it because the plants that produce these electric vehicles have better disposal methods for the toxic uh, byproducts of the mining. Uh, we we're seeing more and more that, for example, car ownership in Canada has accelerated. People are buying and dropping cars within 5 year periods, whereas maybe just 10 or 15 years ago, it would be normal to see a 10-year-old car on the road. You don't see so much of that anymore. Um, and I think part of it has to do with our shift towards electric vehicles. But I don't think that in the long term it will prove to be beneficial. And I think we'll have to find another alternative to that.
Are there any other alternative sources on the table right now? I mean, like you were mentioning hydrogen based or
Um, I think that's the newest one to the group. Uh, it could prove to be useful, but I think they're being a little quiet on that end of development. It's their sole property there, and
got
the
it.
tried and tested gasoline, petrol-based fuel, or diesels even. Um, we have the infrastructure for it right now, and we could keep it going, although it is clearly polluting our environment. it's something that I think is the best way forward while we redirect. There seems to be a craze around electric vehicle development, and I was actually looking myself at a career in the automotive industry because I do like engines, and that's something that I developed over the course of my studies in aerospace. However, I think that, yeah, I do think the electric vehicle market will come to a halt sooner than later, and we'll have to find another alternative that I'm not so aware of at the moment.
And this halt would be more because of things like, for example, limitations you were saying, like changing the battery, right? Which is very expensive for
Right.
an average
Changing the
family.
battery, it's expensive, and I think the battery production is the most environmentally harmful portion of the electric vehicle production and lifetime. Um, so that's the issue, is that I think we don't have the technology we would want in those batteries. However, if we do make those advancements that I'm kind of hoping on for those hoverboard shoes, uh, things could be promising. If our batteries are able to have extended lifespans or um, degrade less over time, for example, much less, we could see that being a way forward in the electric vehicle sense to circumvent that problem.
Got it. What is the difference between the battery production versus gasoline production in terms of the negative effect? Is it more on the battery side, or is it on par with gasoline, or is gasoline more? What are your thoughts on that?
So at this point, if I may be mistaken, I have looked into it, but I think the lithium mining is more immediately harmful to the environment. There's a possibility that that's just because we do have that, as I mentioned, infrastructure for the oil and gas industry already, and that the uh, lithium mining or electric vehicle battery production just has doesn't have that. But I'm leaning towards more so that I do think it's there's not much of a benefit to having these electric vehicle batteries produced, because it is more toxic to the environment than oil and gas harnessing and utilization.
Got it. So the government has made this regulation that, 2035, they're going to stop the sale of gasoline powered vehicles. And the hope is that the electric vehicles will catch on, but that might not happen, right? At that point.
It's possible. It's always hard to, especially in the times we have now, where countries are at the brink of war and the market is on the brink of collapse. Um, it's a very pivotal time, and that could be a plus in the direction of changing the current state and moving towards electric vehicles. However, it might not be,
And we
and
need
it could
someone to
prove.
champion the cause as well, right? I mean, right now we've got Elon Musk, who's the poster person for electric vehicle technology. If there's a different, source of fuel, we need someone to like Elon come and, champion that cause
Right,
and take it into popular culture, right?
right. We need. This goes back to getting that funding, basically, right, and picking the right direction. And no one ever knows what the right direction is. I think most of the time science is a happy accident, right?
Hmm.
We discover things by accident, and sometimes they're beneficial and sometimes they're not. Uh, so one example I have is that, um, well, maybe not an example, but a point I have to bring is that uh, in the aerospace industry, we do consume a lot of fuel, and that's hard jet fuel going there. And the problem with that is that the planes are flying right up there in the atmosphere, where we have those protective layers from the radiation in the universe. And
Yeah.
they don't have time to really, or the particles there don't have time to disperse before getting sent to the atmosphere. They're dispersed directly into the atmosphere. So it's possible that maybe we'll have to also look into that direction for alternative modes of transport and fueling, because it might not be so viable to switch, say, a plane to a battery powered system. The batteries may not be able to carry enough charge for a full trip that, say, a 18-hour flight might take.
Sure. Again, like you're saying, it's, gasoline is tried, tested, and true, right? It's the analog version of the fuel source. And then when you've got, electricity that is fueling your vehicle, I've heard of road trips that have been made nightmares because of electric vehicles. Because once you're stuck, you're really stuck, right?
Right.
It's not like gasoline where you can kind of hack your way out of it, maybe.
Well, I think some people get around it by carrying like a spare jump battery sometimes, but it doesn't get you far because it, the car battery is a lot stronger than that.
Got it.
So you're right. Yeah.
Do you foresee flying cars anytime soon, or is it even
I could.
practical to have flying cars like, the Jetsons or Star Wars
Mhm.
or
I don't think it's practical. There's a couple reasons, but the I think the biggest one is uh, for airplanes we have air traffic controllers, and they are guiding at any time, and say up to 100 flights that might be coming into that airport that day. Um, if we give individuals that third dimension of freedom
yeah,
to move up and down, I foresee a lot of problems, or we could get congestion in the air above us, right? And say traffic above your head, traffic below you, and you could be stuck not moving while in the air. You could maybe run out of fuel there. You could have someone coming at an obtuse angle in your direction that is not guided by a road or by any defining lanes, and then get into a collision with you while say you're hovering in place. So I think, unfortunately, unless there is like infrastructure development, we shouldn't have flying cars.
sure. And an accident could happen twice, right? It'll happen up there. And then, when the cars
Yep,
fall to the ground, that's the second accident that
that's a good point. Yeah.
happens. Yeah, and who knows, where it's headed. I mean, you and me are, sort of at this cusp where, like we're saying, the infrastructure is not ready there. And, we're waiting for the technology to catch up. But I remember seeing in a museum, this was, maybe the early 1900s when cars were coming out, that an ad was put out by the horse and carriage company. And they put an ad out saying to use your horse and carriage because it was much safer than, using a car. And then the
Right.
reverse happened, right? An ad came out for the car saying use the car because, the horse and carriage can break down and then you're stuck. So, and,
Right.
it's pulled us out of, horse and carriages into cars because back then, people didn't think cars were safe. And,
Right.
there was resistance to, get into the automotive culture. And now for us to say, let's use a horse and carriage rather than an automotive vehicle, people would laugh at us, right? Like we're not going back in time. In fact, we
Right.
want to go forward. So, much to
Right.
that mission, who knows where this, can take us. And we might even see it, like you're saying, right? If the infrastructure is built, it could be like Star Wars, where there's a high, network of cars above, cars
Right.
below. Who knows where it's headed to. But again, it's all relating and dependent to the technology, right?
Yes. I think what we have to do to maybe further that kind of development is to get over that inertia, of resistance to change, really. Um, people are comfortable with what is known. And uh, well, the old saying goes, if it ain't broke, don't fix it. But it is broke. And so we do need to fix it. And that's where I think the conflict is between uh, choosing a new development and sticking to it and really keeping our guns trained on the goal. Uh, so it all depends if electric vehicle manufacturers treat this as a phase where they are, say, trying to manufacture a new type of vehicle and milk it for profits for however long they can before actually solving the problem, um, then we might be in for a long ride. But if they capitalize on it and try and make it as efficient or plausible as possible,
Yeah.
then there's hope.
No, those are some good points. I mean, you've got a problem to solve, and not only do you need the technology to solve that, you need the funding to sometimes, garner the technology to solve that. But even before the funding of the technology, you need that mindset, right? You need that
Right.
mental capacity to be able to bring the technology forward, because you're actually putting a lot of trust into this, a lot of confidence and a lot of risk, like we're seeing with, self-driving cars. For you to, fully submit your confidence to them while on the road, that takes a very big shift in your
Yeah.
mindset.
That's a leap.
It's a leap, yeah. So, you can have all the funding in the world, you can have all the technology, but if you're not able to make that mental shift, then you're still stuck on the ground.
Right.
Um, no, that's great. And we hope that the poster person is out there somewhere, and will come forward and do some research, and like Elon did, champion the cause and bring it to the front lines, because as you can see, we're an ever evolving world, and we need the technology to support us as we move forward.
Right.
So Keanen,
And
thanks again for coming on the podcast and sharing your thoughts with us on aerospace. And if people want to, maybe ask a question or get a hold of you, where's the best way for them to reach you?
well, I'll give you my email and maybe you could put it in the description here.
Sure. Okay, that's great. I'll put it in the show notes of the episode. Okay, and thanks again, and I wish you well.
Thank you, Croydon.